All right, if you're gearing up for your MMPC-008 exam, you have come to the right place. We're about to do a super fast masterclass breaking down the core concepts you absolutely have to know. No fluff, just what you need to feel confident. So, let's jump right in.
Okay, so here's our game plan. We're going to start with the absolute basics, the physical foundation, the core building blocks of IT. Then we'll build on that, looking at the software and data that make the hardware useful. From there, we'll see how managers like us use these systems to make really important decisions. And finally, we'll tie it all together and look at the big picture, the strategic value all this brings to a business. Trust me, by the end, you'll see exactly how all these pieces click together.
Okay, let's kick things off with Module 1, the core IT building blocks. And I mean, this is literally the foundation. Everything else we're going to talk about, all the software, the data, the business strategies, it all sits on top of the physical hardware we're about to dive into.
Okay, so a super common exam question is, hey, what are the key hardware components of a network? The easiest way to think about it is like you're setting up a new office. You've got your computer systems, right? Your employee computers are the clients, and the main computer is the server. Now, each computer needs a network interface card, a NIC, which is basically its own personal phone line. The signal travels over transmission media, the cables or the Wi-Fi. A switch acts like a smart office receptionist, directing calls inside the office, while a router connects your whole office to the outside world. For the exam, if you can name 4 or 5 of these and just briefly say what they do, you're golden.
Next up, let's talk about main memory. You can bet the exam is going to ask you to compare RAM and ROM. The one word you have to remember is volatility. Think of it this way. RAM is your messy workbench. It's where you put all the stuff you're working on right now. But when you turn off the power and go home for the night, poof, everything on the workbench is gone. It's volatile. ROM, on the other hand, that's like the instruction manual that's bolted to the wall. It doesn't matter if the power is on or off, those instructions are always there, you can't change them. It's non-volatile.
So what's the whole shebang when it comes to IT infrastructure? What's everything that's included? It's way more than just the computers. Of course, you've got the obvious stuff: hardware, software, the network, and data storage. But here's the secret to a top-grade answer. Don't forget the other 2 parts. You've got to include the human resources, the actual IT professionals who make it all work, and the services, things like the help desk and maintenance. A real infrastructure covers the technology, the data, and the people.
Okay, we've got the pieces. How do we connect them? That's where networking comes in. You're likely going to be asked to explain the different network types, and honestly, it's super simple. It all comes down to scale, to size. A LAN, a local area network, is small. Think one office building. A MAN, a metropolitan area network, is bigger. It connects a whole city or maybe a big university campus. And a WAN, a wide area network, is massive. The entire internet is the ultimate WAN. Just remember, office, city, world. Simple as that.
All right, moving on up to Module 2. So, we've laid down the physical foundation, the hardware. Now let's talk about what runs on top of it, the software, and of course, the data that brings it all to life.
Here's a question you'll probably see. What are the advantages of integrated software applications, like an ERP system? The huge game-changing idea here is creating what we call a single source of truth. See, before these systems, the finance department had their set of numbers, and the HR department had theirs, and they never matched up. By integrating everything, everybody in the company is looking at the exact same data in real time. This gets rid of errors, makes everything consistent, and lets managers make way better, faster decisions. That's the core value.
Okay, the Java environment, JDK, JRE, JVM. This can sound super confusing, but it's not. Let's use an analogy. Think of a restaurant. The JDK, the development kit, is the entire kitchen. It's all the tools, the pots, the pans you need to create a new dish. The JRE, the runtime environment, is the dining room and the plate. It's everything the customer needs to actually run or enjoy that dish. And the JVM, the Java virtual machine, well, that's the master chef. The chef takes the recipe and makes it work perfectly, no matter what kind of table the customer is at, whether they're on a Windows computer or a Mac. That's what makes Java platform independent. Kitchen, dining room, chef.
All right, so you've got all this data. How do you manage it without it becoming a total mess? That's where a DBMS, a database management system, comes in. Think of it as an intelligent gatekeeper for your data. So why is this gatekeeper so important? For your exam, focus on 2 critical jobs it has. First, data integrity. It makes sure the data is accurate and consistent. And second, security. It controls who gets to see what and who can make changes. It also stops people from saving the same information in 10 different places, which, as you can imagine, is a nightmare waiting to happen.
So how do you actually build a huge new software system from scratch without it completely falling apart? Well, you follow a roadmap, a structured process called the SDLC, the System Development Lifecycle. It's a logical journey. First, you start with planning. You figure out what you're trying to build and if it's even possible. Then you do an analysis of what the users actually need. Next, you create the architectural blueprint in the design phase. Only then do you start development and actually write the code. After that comes intense testing to squash all the bugs. And finally, you implement it for everyone to use and then maintain it. This is how the pros build software that actually works.
Okay, buckle up for Module 3. This is where it gets really interesting for us as managers. We're talking about systems for decision-making. So we have the hardware, we have the software, now what? How do we actually use all this tech to make better, smarter business decisions?
So, what in the world is an MIS, a Management Information System? Honestly, the best way to think about it is like the company's nervous system. It's constantly sending the right information to the right parts of the business, the managers, so they can react and make decisions. As you can see, it helps with pretty much everything, from high-level strategic planning to day-to-day control of operations, and making sure all the departments are coordinated and working together.
Okay, let's get a little more specific with a Decision Support System, or DSS. Now, if an MIS is for your regular, everyday reports, a DSS is your special tool for the big, messy, complicated problems that don't have easy answers. For the exam, you need to know its main components. It has a data management system, which is just the database. It has a model management system, which holds all the formulas and analytical models. And it has a user interface, the dashboard the manager actually looks at. Think of it as a toolkit for tough choices.
Super important point. An MIS isn't just one single piece of software. It's really an ecosystem of different tools all working together. And if the exam asks for examples, you'll want to have a few of these in your back pocket. You've got your core databases like Oracle, everyday tools like Microsoft Excel, really powerful statistical tools like SBS for the heavy lifting, and cool business intelligence tools like Tableau to make it all visual. And a lot of times this is all bundled inside a big ERP system like SAP.
So why are we even talking about this? What's the big deal about using computers to help make decisions? Well, the advantages are huge. Of course, you get incredible speed and better accuracy. But honestly, the real magic, the absolute superpower here, is what-if analysis. A manager can ask the computer, hey, what happens if we increase our prices by 10%? Or what happens if our competitor cuts their price? The system can run those scenarios in seconds, letting leaders test out their strategies before making a big, risky move in the real world. That's a game changer.
And that brings us to our final and, you could argue, most important module, the strategic value of information. We're going to shift gears now. We've talked about the what and the how. Now let's talk about the so what. Why does any of this stuff actually matter to a business's bottom line and its long-term success?
We all know information is valuable, right? But how do you actually measure that value? How do you put a number on it? For your exam, you should know these 4 common ways to do it. You can do a simple cost-benefit analysis, you can try to measure the value of the improved decisions it leads to, or you can use classic financial metrics like the payback method, how fast do we make our money back, and of course the big one, return on investment, or ROI. Being able to list these shows you're not just thinking about tech, you're thinking like a manager.
Okay, listen up, because this concept, IT business alignment, is probably one of the most critical things we'll cover. I want you to picture a rowboat with 2 people in it. One is the business, the other is IT. If they don't row together in the same direction, what happens? You just go in circles, right? That's what happens without alignment. So the process is simple. First, you figure out where the boat needs to go, the business goals. Then you see how you're currently rowing, your IT capabilities. Then you develop a plan to get everyone rowing in sync, and finally, you start rowing and make sure you're staying on course. It's about making IT a strategic partner, not just a cost.
Okay, last topic. Let's look at what's coming next, the stuff that's changing the game as we speak. For your exam and just for your career, you need to know the headlines on these key emerging technologies. We're talking about artificial intelligence and machine learning, cloud computing, big data analytics, the Internet of Things, or IoT, and blockchain. You don't need to be an expert, but you need to know what they are and what they do. All right, let's wrap this up with one final thought. The only thing that's constant technology is that it's always changing. Look, anyone can memorize a list of buzzwords. The real skill, the thing that makes a great manager, is figuring out how to apply these tools strategically to create real, measurable business value. That is the core lesson here. Keep that big picture in mind. All right, that's it for me. Now go crush that exam. Good luck.